Yes, such as an algorithm lab, experiment number 7. So in this lab, you're actually asked to make a single linked list, single circular linked list. So before going on to the code, I'll just show you the output. Okay, okay. Just a minute. Okay, so just a minute. I'll just make this more visible. Size. Okay, so first, I'll just try displaying. So list is empty. If my list is empty, I'll first try deleting. Okay, so say, okay, in this thing, the delete option actually asks for a value instead of a position. So I give 100, it shows list is empty. So that edge case works. Okay, now let's insert an element at the front. Say I want to insert 100. Now let's insert an element at the back. Let's say I want to insert 200. Now let me display those elements 100, 200 slide. Let me insert one more element at the back. Say I want to insert 300. Now if you see 100, 200, 300. Let me insert one more element in the front. Say I want to insert 50. So now if I see 50, 100, 200, 300. So this is what. So now let's go to this thing. Sorry, this thing at any position. Okay, like for this, a point to note. This is after the given position. Say if I'm giving 0, then it will insert it after 0. At any position, enter the data. So let's say I want to insert between 50 and 100. So I want to insert 80. Uh, Position 0 because after 0. So if you see now, 50, 80, 100, this works. So let me go to another example. Let's say I want to insert uh, after 200. So enter the data. I want to insert 250. Position will be 0, 1, 2, 3. So after 3, so I will 3. So if you see now, 250 is inserted. So what if I give at the end after 300? Let me go 3. So after 300, I want to insert 350. So 0, 1, 2, 3, 4, 5. So 5. Let me go to this payment. So after paying, it's given 350. So what if the user enters some position which is not there in this given list? That's an edge case, right? So let me check that too. So say I want to insert 400. The user gives me 100 position, but in this case 100 doesn't exist. There are only 1, 2, 3, 4, 5, 6, 7. Yeah, 7, 0, 1, 2, 3, 4, 5, 6. There are only 7 positions. So say let me give 100. Now see, shows given position is greater than the number of elements in the list, adding element to the tail of the list. So that edge case also works. So that, now let me show a delete. First I'll show delete from the front. So 4, enter the value. I want to delete 50. So that will basically delete from front. 50 is deleted. Say I want to delete the value 400. That is delete from last. Now if you see 400 is deleted. Say I want to delete some value in between 250. So for 250, now let's check. 250 is being deleted. So last thing, uh, say uh, for this what shall I give? Okay, last thing, I'll just give some other value to show that like okay, one more edge case is what if the given element is not present in the list? Say for example 450 or 400, even 400 is not present. So that edge case shows element not found, so it won't be deleted. So that edge case also works. So everything works. I'll just exit it. Now I'll show you the code, how things are. Uh, so if you see here, okay, sorry. Mm, exactly. Okay, so this is the code. Okay, so first I have a node class, uh, like that is the building block of every linked list or node class. That is it. Then I made a class for the entire singly circle linked list. Okay. So in this class, I have two pointers, head pointer and tail pointer, pointing to the head and tail. And I'm having a constructor that will initialize head to null and tail to null as you said. Here. So I have insert head function, insert at any position. Then I have insert end function. Then okay, this deleted and delete tail are a complement of this entire function and delete node. They're actually a part of this. Instead of making the code repetitive, I just made it a function. And last one, I have print function. Here's the print function. Yeah, print function. Before explaining those individual functions, I'll just explain you the main. This is to print the identification. This code belongs to me. Here I have three variables: 10, choice, position. So here I'm initializing the list. So this will make head and tail as null. Here I'm asking the user what the uh, user wants to pick from these given options. Then here I'm just getting the user's choice. There's this while loop which runs until while choice is double equal to 0. If it's equal to 0, the control exists in the while loop. So if you see here, 6 is exit. So I have this switch case statement. If case is 1, then it like asks the user for the it asks the user for the data to insert at head, then it calls insert at function. Case it 2, if case is 2, it asks the user for the data to be inserted and it calls the insert end function. In if case is 3, it asks the user for the data and the position where the user wants to insert and it calls the insert at any position function. If case is 4, it asks the user for the value they want to delete and calls the delete node function. Last one, if case is 5, that is to print, which is called the print function. If the user gives any other value, say 7, 8, 9, 10, 11, 12, or any other integer value, this statement will be executed, which is wrong input, try again. Then again, I'm just showing the user the menu and asking this choice after the first operation is executed. So now choice is updated. Again this checking will go on. So now let's go on to the individual explanation of the functions I use. So first the insert head. Okay, so if head is null, that is there are no elements in the list, what happens is we just print list is empty, adding elements, and then we make a new node with the given data. Then we make head tail equal to this address. Head and tail pointing to this new node. Then we make tail of next is equal to head. Reason being is in a single circle linked list, the tail points back to the head so that it is circular. That's why we are making this so that head and tail are connected. And then we just give return to pass the control back to the calling statement. If head is not equal to null, that is there are at least one element uh, in the single circle linked list, then what we do is we just make a new node. Then we do this new node of next pointing to head. Okay, here we're inserting head. So whatever node we're going to make, that should be the current head. So we actually to update head. So that's why we're using n of next is equal to head, and we're updating head to this n of this. Okay, so now as we updated the head, if you remember, tail points to the head, and here we updated the head. That means tail points to the previous value of the head. So we also need to update tail's value. So here we do tail of next is equal to head. This is insert at head position. I'll come. I'll come to this after I explain insert at end. Insert at end, same thing here. If head is equal to null, that means there's no element in the list. So in this case, I just print the statement and I call this insert head of data. Okay, this statement is actually not needed because however we be printing it there. So I just call insert head, which in turn will go here and it will just execute the statement. So at that time, the same statement will be printed. So instead of making the code uh, recurring again, I just reused it. So then, if in case if there's at least one element in the list, then what I do is uh, I just make this new node. Then I say, okay, this node should be the tail. Okay, so we actually to update the tail to pass to. We actually to update the tail to point to this current node that we're going to insert. So after making this new node, I'm just making tail of next. That is equal to n. That is the current tail value of next should point to this. Okay, as uh, as as this is going to be the new tail. After that, I update tail. Okay, and if you remember, in a single circle linked list, tail points to the head. So in this, I need to make this new node point to the head. So as this new node and tail are equal, I just said tail of next is equal to head. So that makes a thing. After that, we go to this insert at any position. So here I have two arguments, data and position. So user will give data and the position where they want to insert after. If you remember, uh, this function inserts after the given position. If I give 0, it will insert at 1, like after 0, after the zeroth node. So if you see, if head is double equal to null, if list is empty, I'm just calling this insert head. Actually, here also the statement. Okay, just a minute. Here, I'm clear. Sorry for the disturbance. Okay, so if you see here, I'm just printing the statement. First printing the statement, and I'm just calling insert head to uh, reuse this part of the code. So that's that. So here I have a variable called temp, which is equal to head. Okay. So if you remember, we actually here in this function, what I'll do is I'll go uh, to the given position, then I'll make the change. So I have this count variable to iterate from like 0 up to that position. So until count is less than position, so say the position is 1. So until count is less than 1, this loop will run. Okay. So what we do is here, if temp of next is double equal to head, okay. If you remember, the tail will always point to the head. Okay? But this is like, if you remember back in the case, I gave 100. I gave 100, but the total number of nodes were only 7. So for that case, it actually takes care of that case. Say like if temp of next is double equal to head, okay. Temp of next is temp of next will only be equal to head when the current temp is pointing to the tail. Okay, so if that's the case, and uh, we are and if the given position is not attained, then what we do is uh, we just bring the statement stating that the given position is greater than the number of elements, adding new elements at the tail of the list, and then we insert at the tail and we return that the call goes back to the calling function. Then what we do is Okay, if this is not the case, if like if the given position is not pointing to the, like, if the given position is not greater than the total number of nodes present, then this will be executed. Temp will be made to temp of next, count will be made increased. So this loop will execute until count is less than position. Once one- like like once count is equal to position, the uh, loop will stop. That is yeah. So if count is equal to the given position, then we actually need to insert it after that given position. So here, okay, here the reason for having this is, what if the given position is at the end of the list, right? Uh, what if, like, say there are three nodes and the given position is 2, 0, 1, 2. So the so the so the so the given position and the tail are similar. Okay, in that case, this will lead to a segmentation fault. So to stop that, I just use this. So I just use insert in, as that does the same thing as inserting the tail after the tail. So insert in. Okay. Um, but otherwise, what happens is I make a new node. Then what I do is n of next will be temp of next. Okay. So uh, like if you remember, say for example, there are three nodes in the list: 0, 1, 2. One will be pointing to 2. Okay. Now if you're going to insert like a new node after 1, then that node should also point to 2. So that's why we give u node of next is equal to temp of next, that is equal to, like that is the same as that is the same as one of next. uh, uh, like uh, like with the given example that I gave. Then what we do is temp of next is equal to n. So after making the u node point to the uh, after making the u node point to the like in that example I gave 0 1 2. In that example 0 1 2, uh, 0 1 2, 1 is pointing to 2. So after making the u node point to 2, I need to make one point to the u node. So for that, I have the statement. So that's it. Now let's go to delete node. Delete node. Okay. If site is equal to null, that means there's no element in the list. Then it just prints list is empty, and then returns a callback. Then I make a I, I make a temporary variable which has the address of head, and I will use this to iterate through the assembly circle linked list. So if you see here, temp of next of data is double equal to value. So what I will do is, in this the user will give a value. I'll be going to the previous node of that value. Say for example the value is 50 and that is in the position 1. I need to go to the position 0 so that I could easily delete the position 1, right? So what I did is I gave this. So if this is the case, there are three situations. Okay, uh, like the node to be deleted is the head. So for that I get temp of next is equal to head, and I made a function deleted to ease in the process. Then another thing, the node to be deleted is a tail. So for that I made one function delete tail to ease in the process. Okay. If both are not the case, then what happens is we just have a new temp variable temp2 that is actually pointing to the node that we want to delete, that is temp of next. Okay. Then what we do is temp of next, okay, uh, is updated to the node that we're gonna delete of next. So imagine we want to delete 50. This was in the first position. So uh, so what we need to do is we actually need to make 0.2. So for that we use these two codes, and then last we delete temp of 2, which is pointing to the node that we want to delete, and then we return the call. So if in case this doesn't happen, then we just make temp equal to temp of next, as we're iterating through the single linked list. Okay, so this will run until temp of next is not equal to head. Uh, it will run until the tail condition. Then it is when 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 temp is double equal to tail, then this will end. Okay, so what if when temp is double equal to tail? Uh, okay, that notes next, that is the head, is to be deleted. So for that we have this. Okay, this is same as the top one. Okay, so I just copy that uh, like uh, like to satisfy that edge case. If all doesn't work, then we just print element not found. That's it. Last function, print. If red is double equal to null, that there's no element in the single linked list, single circle linked list, then what we do is we just print list is empty, and then we return the call to the calling statement. And then for iterating, okay, so for 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 printing all the elements in the singly circle linked list, I actually need to iterate through the entire um, actually need to iterate through the entire list, right? So for that I have a temp, same as the previous ones. So I'm iterating until the tail, okay, and I'm stopping when and I'm stopping when temp is double equal to tail. So when temp is double equal to tail, it stops. Until then, it runs. So for each iteration, I'm just printing the data stored in that node, and I'm incrementing the uh, incrementing, and I'm changing the temp variable to point to the next node and updating temp. After everything is done, I need to print the values to the tail. So for that, I just put here temp of data. Why a temp of data? Why temp of data gives the values to the tail? Because it runs until temp is equal to tail. When uh, like when temp is equal to tail, it stops. So if I just print temp of data, it will print the values to the tail. So that's it, and thank you.